All right, so this morning I wanted to talk about measuring gas pressure specifically because it's getting to be that time of year and I know we do it so rarely. So now that you can pull it up and actually have it on your phone, that will also be helpful, because when you come to a gas appliance, we do need to be checking gas pressure, especially if we are setting it up initially, doing a startup on it, doing a commissioning. That's the most important time, but because we have an entire market where folks don't set gas pressure when they start them up, we do need to be checking that. Now, I saw Jessica pop her head up as soon as I said that, so we're going to work into it. The first time you come to one, you're definitely going to want to, talk through it with somebody. If it's the first time you've ever measured gas pressure, it would be ideal if you did that with somebody. But again, once you know how to do it, it really isn't that complicated so long as you do it in the proper sequence. And to do it safely is just a matter of shutting the gas valve off while you have it open and then making sure you put the plugs back in. But let's just go through it one at a time. So to start with, you're going to shut off the gas furnace appliance. You're going to shut off, that's a weird way of saying that, but you're going to shut off the valve going to it.
The shut off.
You're going to shut off the shut off. Now the technical name for this that's used throughout the country is the gas cock. I feel uncomfortable saying that, so we're just going to call it the gas valve. Number two, once you shut off the gas valve, you're going to remove the inlet and outlet test ports on the gas valve. Now, this is the most common gas valve type that we see. There is another version that you don't actually remove plugs, you actually just crack it. If you come up on one of those, they call it the, I don't remember what they call it. This
crack
is
valve.
No, it's not called a crack valve. That's not it.
Whatever it is.
What's that?
It's inappropriate, whatever it is.
It's probably something inappropriate. There's a lot of that in our trade, I did a video about that actually, about all the inappropriate terms. Huh?
The butt crack valve.
No, that's not what it's called. Anyway, it's basically a valve that you place your little hose adapter directly on, and then you just crack it open in order to measure, and we'll do a separate class on those at some point. But this is the standard valve that we see in our market most often. And I actually already did an article on this, so I'll find it and we can link it. Once you remove both of these ports, then you put these barbed fittings into each one. Now this is pretty important because a lot of you are using manometers that don't measure independently. They measure only to each other. And that creates a little bit of a problem when you're doing this, because then it's only going to show differential between the two ports. So you have to know, is your manometer measuring differential in between the two ports, or is it measuring independently in reference to atmospheric pressure? I'm going to say that again real quick because this is kind of an important distinction to make. Every time you're measuring something, you're measuring it in reference to something else, just like we talked about in the voltmeter. You can't take a voltmeter and take one probe and stick it in an outlet and measure anything. You have to measure between 2 points. You're always measuring a differential. And the same thing is true with a manometer. If you have a single port manometer, what you do is you zero it to atmospheric pressure, then you connect it to the valve and you measure that pressure. And it could be either negative or positive in reference to atmospheric pressure, like in the case of measuring static pressure. When we measure it in reference to the room, to the return, we're measuring a negative pressure. Now, quick trick question, just so we don't get too backwards on our science here. Is there such thing as negative pressure? No. Why is there no such thing as negative pressure? Bert.
Because low pressure is just less matter in an area.
Right, correct. So
when you get down to zero, there's just no more matter.
Correct. And you can't get less than no matter. You can't get less than no molecules.
No matter what you do.
No matter what you do, you can't get less than no matter. Which coincidentally is why you can always produce more force through pressurizing than through suction. Right? Like when you pull when you take a shop vac, I've just been thinking about this because we just did a podcast about cleaning drains. When you take a shop vac and you hook it up to a drain line outside, what is the most pressure that shop vac can produce in order to suck water out? The very most theoretical limit that shop vac can produce. Now, the kit doesn't produce anything. All it's doing is moving stuff, right? But from a theoretical standpoint, the lowest vacuum that it could produce is negative 14.7, because atmospheric pressure is 14.7 psia, right? So whenever we're saying vacuum, there really is no such thing as vacuum really. There's just pressure that's lower than atmospheric pressure. So the theoretical maximum that a shop vac could produce is negative 14.7 to suck snot out of a drain line. Make sense?
Recognize.
So you have, and of course that's not going to happen. It's not even close to that, but you get the point. That's the theoretical maximum. Whereas if you're using nitrogen or air pressure, what's the maximum of positive pressure you could produce? Infinity, right? Below the drain to kingdom come style pressure, right? So that's the problem, but that's also the reason why you can do more with pressure than you can do with vacuum. Just a quick aside that has nothing to do with what we're talking about. Other than that, when we're referencing a manometer, we're always referencing to something else. And you need to know, is your manometer designed to reference A to B from point 1 to point 2 on the 2-port manometer, or does it reference both of those and to the center? And that's what this field piece manometer does. It gives you the ability to reference the two to each other, so you can see the differential for something like total external static pressure. But then you can also reference to the center so that you get each one of those independently. My favorite current manometer is the new field piece job link manometer, just because it works with the suite that we're already using, the job link probes. And it is a single port manometer, which means you zero it to atmospheric pressure, or whatever pressure you want to reference to, and then you take the measurement. But in terms of measuring gas pressure, measuring the inlet and outlet simultaneously just makes sense. First off, because it's much easier to shut the gas valve off once, the inlet gas shut off. Anyway, to do that once, and then pull both the ports, and then put both of your probes in, zero out your manometers, and then go ahead and start measuring inlet and outlet pressure simultaneously. Because what you don't want to do is, let's say you start doing it, and then you measure that your outlet pressure, your manifold pressure, the pressure actually going into the gas furnace or gas appliance, is too low. I don't want you to start adjusting the valve right away, because there's two reasons why it could be too low. What would be one reason?
Restriction.
It could be that it doesn't have the right gas pressure coming in. So Matthew said restriction. Sure, it could be. It could be that the gas line is too small. But it could be that the gas valve is set inappropriately, and we don't know which unless we're measuring the inlet pressure coming into the valve as well. So we remove these ports. These ports, you can use a Allen key, or you can use the 3/16 Allen key that comes on your refrigeration service wrench. So the one that we use to open the service valves, that works on this type of port design. And again, we're in Florida, mostly 80% gas furnaces. This is by far the most common valve type you will see. Now, they're not all going to be sitting right up here on top like that. Sometimes they'll be, they can be in different locations, but you're going to have one little port on the inlet side, you're going to have one little port on the outlet side. Everybody following me so far? Anything super complicated here or scary? No, it's not. It's very straightforward. We put our little Barb Fittings in. Now you got to have the Barb Fittings. It's another thing I like about the field piece kits is they come with them. They come with the Barb Fittings, they come with the hoses, they come with all the stuff you need in order to measure gas pressure and static pressure, which is the two things you're going to do with a manometer. Quick show of hands, who doesn't have a manometer here? Okay, the video guy doesn't have a manometer. We need to get you one of those, Nate. I mean, what are you doing? So some of you who are newer, some of you who are still apprentices don't have them, but you do need to have a manometer, because you can't check either of those things unless you have one. And in terms of gas pressure, if you don't have a manometer, you really are guessing. And if you get to a place where the flame is not looking quite right, or you're not getting the performance that you expect, the next thing you need to do is adjust gas pressure, and you absolutely cannot do that if you don't have a manometer. All right, so once you insert the fittings, you put the hoses in, you see you just thread them in. A lot of people get real worked up about taking these things and really tighten them down. You don't need to do that. You just finger tighten them in. Because again, a tiny bit of gas leakage around that valve, I mean, again, you wouldn't want any significant, but...
Yeah, just a little.
Go ahead, say it.
I was just going to say, you just put a little pressure on them.
Okay, just make sure they're in all the way.
1 foot pound.
Well, just make sure they're in all the way. What I see a lot of people do the first time they do this is they take these and they put a wrench on them. That's not necessary. I mean, you can if you want, but I don't want you tightening them down. I don't want you messing up the threads on this thing or messing up your Barb fittings because you're trying to get these things super, super tight. So anyway, once you get those in, zero out your manometer, make sure that it is zeroed to atmospheric pressure. That is critical. A lot of mistakes are made both with static pressure and with gas pressure by not zeroing the manometer. Now, there are cases, and I'm just paying homage to people who work with 90% sealed combustion furnaces. When you're working with the sealed combustion furnace, there is no reference to the pressure in the room. The reference is the pressure inside the furnace because it's all sealed combustion. And that's where you need to make sure that you're not zeroing out to room pressure, you're zeroing out to the pressure that's inside the furnace cabinet. Most of what we work on is what we call open combustion, where you've got the louvers on the front of the gas furnace, and that's where the combustion air and oxygen draws in for the furnace to work safely and properly. Which is another quick aside, one of the most important safety things you can do is make sure on our market that you don't have furnaces in sealed areas that don't have access to free and open air. So this is why when you have a gas furnace in a closet, it's got to have some nice vent space up into the attic or some other area that it can easily get enough oxygen consistently. And again, this is another consideration. You go into a house that had access into the attic, but then you've icing the attic. Seal it up really tight. Now, sometimes that could be okay, and this comes down to there's a lot of calculations that have to be done, but generally speaking, you don't want to have a gas appliance in any sort of sealed area that it cannot get free oxygen from outside. That's just a good general rule. You get into contained versus uncontained spaces and all that, but for our market, just make sure it's got enough oxygen. All right, so you zero out. Now you open the gas shutoff. As soon as you open the gas shutoff, you should see pressure on which one of the ports? Input. The inlet, right? So this guy right here. This is our inlet coming in. I'm going to start seeing pressure there. Now, I'm going to check it right then and there, but the reality is that it's probably going to be fine to begin with. Because it's just like measuring water pressure on your house when no faucets are running. Your water pressure on your house when no faucets are running are probably going to be fine. Now again, I'm on a well system, so I face this problem all the time. Most of you are in city water, have never had this issue. But when you have a system that can't produce enough water flow, your pressure will be fine so long as nothing's running. That's what we call static pressure. But as soon as you start running faucets, now the water pressure drops down. That's what we call dynamic pressure. So if nothing's running, if the gas furnace isn't running, I'm only measuring static pressure on the inlet. As soon as I run the gas furnace, now that's when my inlet pressure is going to tend to drop. So I open up the gas shutoff, now I run the appliance in heat mode. Once I start running the appliance, I need to make sure that the inlet pressure maintains above the minimum inlet pressure. And where do I find that data about what the inlet pressure should be and all that?
Data tag.
Data tag, it is right there. I mean, they put it right there on the data tag. Nice and easy, nice and pretty. It tells you what your inlet should be. It tells you what your manifold pressure should be. And manifold pressure is another term for the outlet pressure of the valve. The pressure going into that manifold that then feeds the spuds on the gas furnace, the actual orifices. All right, so we run it. Now we check our outlet pressure as well as our inlet pressure simultaneously. Make sure our inlet pressure is still what it needs to be with the furnace running, and then check our outlet pressure. Outlet pressure should be between 3.2 and 3.8 for natural gas and 10.5 to 11.5 for propane, but follow manufacturer specified pressure ranges, because when I say this, that is a general rule. That is not an absolute rule, but it is pretty solid. It's going to be typically what you see with natural gas and propane appliances, LP appliances. All right, turn adjustment screw clockwise to increase outlet pressure and counterclockwise to decrease outlet pressure. Now your adjustment screws can be in different locations. The most common look, if you see this brass cap right here, see this brass cap back behind the inlet? Yeah. You take that brass cap off, and then underneath that brass cap is an adjustment screw. It's usually a plastic type of material adjustment screw. And you want to turn it clockwise to increase gas pressure and counterclockwise to decrease gas pressure. So it functions more like a acetylene regulator or an oxygen regulator, where it's not how you think. It's not like you open it up like a valve in order to get more pressure. You actually turn it down in order to increase the pressure. So you're turning it clockwise to increase. Now you're going to see that. So it's not like, I get a lot of people, well, I can't remember which it is. Well, obviously, as soon as you start adjusting it, you're going to see your manifold pressure change. And if you're going the wrong direction, start turning it the other way. I mean, I don't know about you, but I still struggle with righty-tighty, lefty-loosey sometimes when it's in a weird configuration. It's like, oh, that's the wrong way. Go the other direction. Oh, I just snapped the head off. That's a bummer. Maybe I should memorize that at some point. So anyway, make sure that you're measuring inlet and outlet pressure, not differential pressure. This is key. This is kind of what we just talked about. you got to make sure that you're measuring those separately and not the differential between the two. Make sense? And that's knowing your manometer. If you use the ones I suggest, then you're not going to have this problem because they make it really easy. Once you're all done, arguably the most important part of this process is you shut the gas valve back off again. You replace those original ports. Now those ports you want to make sure are in nice and snug. And I would suggest using a little bit of our new Nylog White, which is going to be our, I don't know if you've seen it yet. Have you seen it?
No.
Nylog White? No. So it's great because it works on water and gas, and it's very smooth. It's almost like a silicone. It doesn't dry. I'm actually really excited about it. I think it will make some things a lot easier. What do you think about it, Bert?
It's great.
It's great, isn't it? Yeah. But it's nice because you don't have to keep various types of pipe dope on your truck. You've got the same pipe dope that we can use for water and gas. So drain lines, whatever. Plumbing in your house, whatever you want to use it for. Not refrigerant. On refrigerant lines, what do we use? Nylon blue. That's right. It's always a bad time when somebody says whoops. I've been using pipe dope on it the whole time. Right on my flares.
When you're out of pipe dope, you just use mastic.
A little mastic, yeah. Now, I want a quick caveat here, which is that when we do commissioning of gas appliances, we also do combustion analysis, because that is a really good part of the process to make sure that we're not going to start up a new system and have a dangerous condition. But Max, in as many combustion analyses as you've done, how many have you actually found a problem with excess carbon monoxide right off the bat? Yeah, it's not. Yeah, it's just, it doesn't happen. Now, when I say it doesn't happen, of course it can happen, and it is generally related to significant venting issues or combustion air. But most of the real problems you're going to catch with a gas furnace, you're going to catch by being visually aware. Venting, not done properly. Now, 80%'s pretty easy, but if you had a vent that was completely disconnected, that would obviously be a problem, right? So that's one thing to look for. Looking for combustion air in our market is probably the biggest. And then also just making sure that nothing's leaking gas. You know, everything's assembled properly. Those of you who don't have a combustible leak detector need to get one. That's a really good safety step. And again, you're not going to find it all the time, but if you're doing maintenances on gas appliances, just grab that combustible leak detector, just run it around all of your connections and make sure that nothing is leaking. It's a good safety step. Another thing is when the gas valve is off and you have gas pressure, the gas valve shouldn't be leaking through any significant amount. So you shouldn't measure, you know, it shouldn't be leaking through enough that you're going to be measuring gas.
We can share Bert's video on finding gas leaks.
We can share Bert's video on sniffing them out with your sniffer. And that is actually another really good point. Take complaints about smelling gas really seriously. Don't be dismissive of those complaints.
And it can be any gas appliance, so it could be the water heater,
Yeah.
it could be
Yep.
the dryer, it
Could be the range,
stove.
yep. Could be the range, yeah. And that's another really good point, is that sometimes you'll have intermittent problems with gas appliances that occur because when the entire house is under maximum load, that's when the gas pressure is dropping. So when you have kind of weird intermittent problems with gas furnaces, you want to run all of the gas appliances and then check your gas pressure. Because you can have issues where you can get rollout, you can get all kinds of issues where if the actual inlet gas pressure is dropping when you have multiple gas appliances running at once. Now again, it's not like we're going to go on every maintenance and run every gas appliance in the entire house. But in terms of kind of the sequence here of getting better and better at gas, start with being really good at your visual inspections. That's the first and most important thing. Second, check your gas pressures. Third, check for carbon monoxide in the space. Use your just personal carbon monoxide detector and just make sure that you're not getting carbon monoxide around the furnace or inside the house anywhere. That's big. And then kind of the granddaddy is to start doing combustion analysis. And we've been walking this path over the last several years where we're first getting really good at making sure the furnaces we install, we're doing all of this. And now getting to the place where we're starting to get better at doing it when we maintain them. Again, we don't do a lot of them, but we do enough of them that it's an area that we can definitely improve. But start by measuring gas pressure. It's always a challenge because it's one of those tools that kind of sits on the shelf and doesn't get used a lot. And then when it's time to use it, it's like, well, does it have batteries? Does it whatever? I mean, a big thing with any of these sorts of instruments is keeping extra batteries on your truck. AA's, AAA's, 9 volts, right? You need to keep those on your truck. Plenty of extras. Happy for you to get extras. If you see that we run out, tell Nathan Bishop, hey, buy a ton more of these. I don't care. I want you to keep batteries on your truck. So those 3 need to be truck stock. You need to have plenty of them, and so that way you don't show up and, well, I can't test it because my manometer doesn't have
Having a good
batteries.
place for your batteries is crucial. Because any moisture, even when they're in the plastic, any moisture, anything like that, oil, it just destroys them. So having a nice, clean bin that doesn't have any moisture buildup is beneficial.
Yeah, a good place for your batteries is big. A good organization in general is important, and that's what a lot of times gets in the way of doing more advanced procedures.
That's right.
Now having seen this, does anybody feel uncomfortable checking gas pressure? Where is the biggest, go ahead, Bert.
I feel uncomfortable with people checking gas pressure unless because you went on a long time about zeroing out to atmosphere pressure, but you need to point out that unless your manometer has a atmosphere pressure port like shown in that picture,
Right.
which is pretty rare, you're still going to have to hook up on each side of the manifold or have 2 manometers going at once.
I felt like I covered this pretty well.
Half the class.
Didn't I?
did,
I was asleep.
But no,
It's
I'm
fine.
saying that a majority of your manometers, you're going to have 2 hooked up at the same time in order to check.
I wouldn't say the majority. I would say the majority of the really cheap ones,
Yeah.
i.e. the one you probably have.
No, I have that one.
Oh,
Or
no, that was mean. Yes, step 1,
So
know your manometer. Go ahead.
Say you have a cheap one. How do you do it?
Okay.
That's all I was going to ask.
throw it in the trash.
If you have a cheap one, the cheap one references between the 2 ports. So meaning it's just measuring the differential between the 2 ports.
Right.
And if that's what you've got, you're going to have to do them one at a time.
Correct.
You're going to have to measure.
Running though.
You're going to have to, and again, I would just do the manifold pressure to start with. So if I have one of those, I'm not going to do the inlet pressure to start with. I'm just going to do the manifold pressure. So I'm just going to do this side first, going out into the gas furnace. If this one's pressure is fine when it's running, then I'm not going to worry about it. Right? That's because likely it's going to be fine. We don't want to go around adjusting gas valves for no reason. We adjust them when they're outside of the manufacturer specified range, which is generally going to be 3.2 to 3.8 inches of water column.
Boom.
Boom.
Yeah.
In terms of visual inspection, I just quickly, what are you looking for when you look at a gas furnace? We are really lucky in Florida because we have these 80% that are actually very easy to look at the flame. You know, everything is very easy to see in an 80%. Step 1, do not run a furnace with the lower panel off. Okay, so like it has the door switch, but a lot of people, you put something on the door switch to make it stay on. Don't run a furnace with the blower panel off. Do you understand what I'm saying? Because what happens is that now it's sucking air through right around the furnace, and those 2 things aren't supposed to mix, right? The gassy part and the airy part aren't supposed to mix. So you want combustion air to pull in through because you have that inducer, as well as the natural convection of the flame to draw that air into the face of that 80%, but you don't want to have rollout or to have carbon monoxide or any of that stuff, and obviously it's going to act weird if you have the panel off. So have the panel on, start the furnace, and what you want to see is, because initially that flame is going to fire. You know, you're going to either see your hot surface igniter, or you're going to hear the tick, 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 and then whoosh, right? Now you got your flame. You're looking at your flame. What you're looking for is that flame to be a nice, clean looking, you know, generally pretty much blue flame. It's going to be typical. Again, if you're working with like, you know, super old furnace, maybe not, but your modern furnaces, you're going to see that nice blue flame. It shouldn't be like where one of them is like cockeyed and like hitting the side. It shouldn't be where anything is loose or like pointed different directions. And then when that blower starts, because on a furnace, first it lights, and then it runs for a little bit, and then the blower starts, right? When that blower starts, you shouldn't see the flame start going on you. It's just like that, just like that. You don't want to see that. What?
It's consistent. I will say, every time you say that, because you've said that exact thing, you did the exact same thing.
Right, yeah, that's what it does. Well, you can count on it, right?
Of a wiggly flame.
A wiggly flame, right. And so if you get a wiggly flame, it doesn't matter, it does matter why. You have to figure out why you're getting a wiggly flame. And most commonly you're getting a wiggly flame because you've got some air leakage into the combustion chamber from the air side. And usually it's something you can fix pretty easily, right? So just see, like where's air communicating in between these two? But the worst case scenario could be a heat exchanger crack. In our market, we see very, very few heat exchanger cracks. We have such a small heating season, and heat exchanger cracks occur because of a lot of heat cycling over time, on, off, on, off, on, off. That's what causes them, generally speaking. So we get precious few of those, but it is something that is real. If a heat exchanger is known to be cracked, then we need to replace it or replace the furnace. But in the grand scheme of things, it's actually not the most likely cause. It's actually one of the lower likelihood causes of a really dangerous furnace. The most likely causes are improper venting, where it's recycling flue gases back into the home somehow. It could be because, it could be something as simple as an intake on a fresh air that's sitting right next to the gas furnace flue pipe outlet. So just dumb stuff like that. Those are the sorts of things that you're going to want to look for. And then finally, in terms of inspection on a furnace, just look for stuff that looks like it's been getting hot. Wires, anywhere around the heat exchanger box, anything that looks like it's been getting hot, or screws that look abnormally rusted for some reason. That can be condensation issues. There's things like that can happen. But mostly, you're going to catch this stuff if you're really just paying attention. You're doing a good physical inspection. On pool heaters, like we've talked about, it's mostly corrosion related. And if you've got a pool heater that's falling apart on you, shut it off and write it up. They're not safe when the burner's fallen down, and there's no way to fix that. Do not write up for quote the customer a new burner. It's not going to go back in. I mean, how many times has that happened? Where it's just like, yeah, quote the customer it's like, no, you can't. And now once you've opened that Pandora's box, now the customer just thinks you're trying to rip them off. But once the frame is rusting out on a gas pool heater, you need to just replace it.
And I will say on gas pool heaters, for some reason, a lot of these builders put in 400,000 BTU heaters.
Right.
And if you look at the pipe size required for 400,000 BTU, usually it's insufficient.
Right.
I like dropping that down to a 250 on small residential pools.
It makes life a lot easier in terms of piping size, yeah.
It's so much better, and I've seen consistently that the gas pressure issue that sometimes we have on these 400s kind of disappears once you drop down to 250.
Right. Right. Again, like what's going to happen? It's not like they're just not going to get their pool as hot as fast. Is all that it's going to come down to. But who cares?
You think about it. I mean, most of these pools have heat pumps that are 140,000 BTUs on the top end.
Right.
At 65 degrees. And now you have a gas heater that produces 80% of 250.
Yeah, and we can tell the customer that. It just solves a lot of problems by going down to a 250, and it's less expensive. Like we're obviously not trying to scam them because we're charging them less for the pool heater. So it's just in everyone's best interest at that point. So that's always something to look for on those appliances. We don't generally see gas furnaces that are installed with undersized gas lines.
Furnaces are still oversized significantly because most of the matchups.
Oh, matchup problems,
Problems, so it's always a little bit tricky. So we've gotten a lot better at actually reducing furnace size, but
yeah, it's a challenge in our market. So cool. Any questions about any of this? No? All right. Thank you. Have a great week. Happy Thanksgiving. Thanks for watching our video. If you enjoyed it and got something out of it, if you wouldn't mind hitting the thumbs up button to like the video, subscribe to the channel, and click the notifications bell to be notified when new videos come out. HVAC School is far more than a YouTube channel. You can find out more by going to hvacrschool.com, which is our website and hub for all of our content, including tech tips, videos, podcasts, and so much more. You can also subscribe to the podcast on any podcast app of your choosing. You can also join our Facebook group if you want to weigh in on the conversation yourself. Thanks again for watching.